So hello guys, welcome back. We are in process of learning advanced DSA and we have started with our sorting algorithms. Advanced DSA and we have started with our sorting algorithms. Okay. And in sorting algorithms, we have already covered bubble. If you have not watched it, watch it first. And we have already covered your selection sort. We have already covered selection sort. So bubble is done. Selection is done. Now it's time to learn a new sorting algorithm, which is my insertion sort. Very simple, just like bubble and selection, but little bit different as well. Now what I will do, before I start, I will just give you a walkthrough of my website www.bigdatayatra.com. In this website, you can find two courses, Big Data and Apache Spark Mastery course. This contain all the skills which you need to become data engineer in 2026 or even after this, because it will help you to build your foundation. It has Hadoop, Big Data, Spark, Python, DSA, SQL projects, resume building and whatnot. And then this is a separate module of Python and DSA. We have been posting daily reels, tech reels on Insta as well. This is our handle, Big Data Yatra. You can follow us. You will definitely like our content. Now, back to the topic, insertion sort. So in insertion sort, let me do one thing. Let me create one array and start the manual run. So say suppose I have 7, I have 3, I have 11, I have 4, I have 6, I have 1. Let's say I have this array. I have this array. Okay. So if I have this array, how many elements I have? I have 6 elements, correct? 7, 3, 11, 4, 6, 1. What will be the index? Index will be 0, 1, 2, 3, 4, 5. Now, first point about insertion sort is, if I have only one element in array, if I have only one element in array, it is already sorted. It is already sorted, which is correct. Say suppose if I have array of size 1, that is only one element. Say suppose in this case I have this array like this, a equal to just 7. So only one element, then it is already sorted. No need to look out or sort the array having one element, right? So this you should remember. So for that what we do, we start scanning from first element or second element present at first index. From second element present at first index. Present at first index. Very, very important point about insertion sort. That if array is of size 1, it is already sorted. If it has more elements, start from the second element which is present at index 1. Start sorting from that. Okay. So what we will do, I will just tell you the manual run. It's very, very easy, not too tough. If you have noted it down, let me just clean it up and let me start the manual run. You will yourself see it's very, very easy. Very, 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 very easy. Right. So what I will do, as I discussed, I will start from this point. I will start from this point, assuming that this side is already sorted. This is already sorted, right? So I will start from first index, this we know. And then what I will do, I will compare 3 with 7, right? Whether 7 is greater than 3 or not. You tell me. Yes, it is greater, right? So what I will do, I will just swap these two or replace these two. So 3 will come here, 7 will come here after my first iteration, right? What will happen? 3 will come here, 7 will come here, and now I have these two as my sorted, right? Because now you will say why these two are sorted? Because 3 is here, 7 is here, these two are sorted. And my assumption was, if array was having only this, it is already sorted. Now if I added 3 to the correct position, or if I inserted 3 to the correct position, then this is also sorted, right? Because 3 is present at correct position. That's why it is called as insertion sort. We are inserting the smallest element at the correct position in a sorted array, right? We have inserted 3 at the correct position. Now what will happen? I will be incremented, or we will go for the next element. We will come here. Now listen to me very carefully. What will happen? Now I have two elements. I have two elements in the sorted array. Now I have 11, right? So I have this 3, 7, which is sorted, and then I have 11. Okay. So 11 will be compared with 7 first. Now you yourself see 7 is greater than 11. No, 7 is already smaller. 7 is already smaller. So do I need to swap? Do I need to swap? No, because 11 is greater or 7 is smaller. And also tell me, do I need to compare 11 with 3? No. Why? Because if it is already sorted 3 and 7, and if 11 is bigger than 7, then why to check for 3? Why to check for 3? This will be a redundant check, or this will be an unnecessary check, right? Because 7 is already greater than 3. I know, because the array is sorted. And if I have already compared 11 with 7, and 11 is already greater than 7, then why to compare with 3, right? I hope you are getting. Then what I will do, simply I will not swap any of the elements in this case. So now my sorted array, what it will become? It will become like this. It will become like this. Now this is my sorted array, 3, 7 and 11. These three are sorted now, and my I will be incremented, or I will jump to my next element here. Now 4. For 4, I will compare with all these elements. Now first, 11 is greater than 4. You yourself tell me in sorted array. Yes, it is. It is greater. So what will happen? What will happen? 4 and 11 will be swapped here. 4 will come here and 11 will come here now. Right? You agree or not? You agree or not? Yes. Then okay, let me just do one thing. Let me not just change it. Let me just keep this is like this only, and we have like this. Now 4 will be compared with 11. 11 is greater, so 4 will come here, 11 will come here. I know. Then 4 will be compared with 7. 4 is smaller or not? Yes, it is. So what will happen? 7 will come here, 7 will come here, 4 will come here. Then 4 will be compared with 3. 3 is already smaller, so it will be like this. 3, 4, 7, 11. So now what I have after this? So you saw in this, I was at this point and it got compared with all the elements of the sorted array from right to left. From right to left. First I compared with 11, then I compared with 7, then I compared with 3, and then I inserted 4 to its correct position. So now what I have is, I have is like this. 3, and then I have 4, then I have 7, then I have 11, right? These 4. And now my sorted array is like this. Now I have my sorted array like this: 3, 4, 7, 11. This is my sorted now. Now similarly, everything will happen for 6 as well. Everything will happen for 6 as well. What everything? Let's see. I am at this point now. Now 6 will be taken and it will be compared from all the elements of the sorted array starting from 11, 7, 4, 3. Right? Now 11 is greater than 6. Yes. Then swap it. 6 will come here. 11 will come here. 7 is greater than 6. Yes. Then swap it. Then swap it. What will happen now? 6 will come here. 7 will come here. Now 4 is greater than 6. No. No, right? Then 4 will be here. Now I know 4 is already smaller than 6. Then why to check for 3? I will stop it. I will stop at this point only. While scanning from right to left, I will stop at that point where I found one smaller element. 4 is smaller than 6. I will not check for 3. Right? This we have already seen. So now my condition is I have 3, 4. How my array is looking like now? 3, 4, 6, then I have 7, then I have 11. And all these are now sorted. 3, 4, 6, 7, 11. All these are sorted now, right? Now we are left with only one element, and which is the smallest, 1, right? On the right side. So now my eye will be here. Now I will be pointing to here, the last element, 1. Now again, for 1 also, I will start scanning from right to left. I will start scanning from right to left in the sorted array, right? Let's see. 11 is greater than 1. Yes, swap it. So 1 will come here, 11 will come here, right? Now 7 is greater than 1. Yes, then swap it. So what will happen? 7 will come here, 7 will come here, and 1 will come here, right? I have this. Then 1 will be compared with 6. Yes, 1 is the smaller. So 6 will come here and 1 will come here. I hope you are getting. Then 1 will be compared with 4. 1 is smaller. Definitely 4 is bigger. Then what will happen? 4 will come here and then 1 will come here. Then 1 will be compared with 3. 3 is bigger. Then again swap will happen. Then what will happen, guys? 3 will come here, 1 will be here. Now I don't have any elements. So this is my final sorted array. This is my final sorted array, which is your 1, 3, 4, 6, 7, 11. So this is your insertion sort. I hope you have got it. Take the element, start scanning from right to left in the sorted array. If the element in the sorted array is already smaller, no need to check it further. No need to check it further. For example, in this case, when we were inserting 6, 4 was already smaller than 6. Then we didn't check it for 3, right? But in case of 1, we checked for all the elements because 11 was bigger, 7 was bigger, 6 was bigger, 4 was bigger, 3 was bigger. So then we got the sorted array. Let me just go to the pie chart. And what will be the time complexity, guys? What will be the time complexity? Let's just calculate the formula. As we discussed, we'll start from I1 to length of array. This will be my very first loop, right? This will be my very first loop because I am starting from the second element and I am going till the last element. And last element in this case will be 5 because length of array is 6, right? And I know range will run from 6 minus 1 because end is exclusive. 6 will run, so I loop will run from 1 to 5. So this is what I want: 1 index, 2 index, 3 index, 4 index, 5 index, right? Now another loop J, it will run from right to left. It will run from right to left, right? So J value will be initially I minus 1. Why? Because if I is here, then I will start scanning from this direction, 4, 3, 2, 1. So J will be from I minus 1 and it will go till my last index, that is 0. And as end is exclusive, so it will be minus 1 plus 1, it is 0. It will run till 0 index and step will be my negative. So these two will be the loop. As we know, 2 loops scanning the elements of the array, so time complexity will be O(n) square. Watch my time complexity video to know it more. Let me just go to the PyCharm and implement it. So I will have one array. Let me just do the same. Let me just take the same array which I took. Yes, let me just take and let me just create it. I don't remember. 7, 3, 11, 6, 4, 1. Let's take this 6 elements, index 0, 1, 2, 3, 4, 5. So I will start from 1 till length of array. Let me just rename it, do ARR, so it is bit clear. So I will run till length of array, right? I will start another loop. What? Another loop. J will run from right to left. So I minus 1 till minus 1 index, which is 0th index because end is exclusive, and step will be negative. Correct? This we know, right? But before that, here I will create one variable where I will store the current element which I am comparing, which will be array of I. Say suppose for 3, for the very first time, current element will be 3, right? So what I will check now, if array of J is greater than current element, guys, if array of J is greater than the current element, what I will do, I will just swap right? And we can improve this. I will show you the improved version as well. What we can do, we can just swap array of j, and what I will put in the array of j, I will put array of j current element, and in array of j plus 1, what I need to put, array of j. Swapping happened. And if the very first element itself is greater, for example, in case of 11, right? In case of 11, 7 will be here, right? When I will start scanning for 11, 7 will be here, 3, 7, right? And then I will check for 11, right? So 11 is already greater than 3. Then no need to compare it with 7, correct? So if this condition is false, if current element is already greater than the previous element, then no need to scan for entire array. I will just break the loop. And I will just print the array. This is my nothing but insertion sort. But again, having said that, I will improve this. This is not the final, because in this we are swapping a lot. I can improve it. Let me just run it and show you. 1, 3, 4, 6, 7, 11. Array is sorted, but can I improve it? Yes, I can improve it. How I can improve it? By reducing this swapping. And how I can reduce the swapping? Let's see. First, I will maintain a minimum index where I want to insert the element. It will be I. Say suppose, yes, the minimum index will be I when I will start from 1 to length of array. And then what I will do, instead of inserting here current element to j, I can maintain just the minimum index where I want to insert. I can update it minimum index to j, right? And then I can simply insert this current, because we are inserting current element to j, right? So in the end only, I can do array of, after the j loop, array of minimum index current element. What I have done, instead of swapping for every j loop, I am just swapping it after the j loop finishes, and I am just maintaining the minimum index, because you yourself see current element is getting inserted to j. So what I can do, I can just remove this. Part. Instead of doing for every j, I will just do it for one time. That's it. This is my insertion sort. Let me know if you have any doubt. I guess no. Let me just run it. 1, 3, 4, 6, 7, 11. Yes. What I'm doing here is I am running from 1 to length of array. J is running in from right to left. I minus 1, minus 1, minus 1. If the element is greater, then maintain the minimum index. Instead of swapping every time current element, just maintain it and insert it the last. If the very first element on the while scanning from right to left is smaller, then just break the loop. No need to check for other element. So this is your insertion sort. Time complexity is O(n)². I hope it is clear. We'll meet in the next session, and now we will cover merge sort, quick sort, etc. So see you. Bye bye.